When we are speaking about metals and non-metals, the first thing we are getting in front of our eyes, that is, metals are hard. Metals are hard. And when we are looking at metals are hard, that means their melting point and boiling point is higher than the non-metals. About lustrous, if you say lustrous means they can shine. Metals can shine. Some metals are not shining, but maximum metals are shining there, but not shining there. And about non-metals, they are not non-lustrous, means they don't shine, as well as they having their very less boiling point as compared to metals and melting point. Okay, if we take the example of their our iron, and if you see the iron which having the required high melting point, high heat, then only it can come into the water. So this means water means iron water, not our regular water. Remember this. So metals having the high melting point, high boiling point, and non-metals having the less boiling point, or so we can say very less than the as compared to metals. Next point, Apurva told that that point is about the malleability. Malleability was what is the malleability? Could tell me.
Metals, upon heated, are converted into sheets.
Yeah, we can see their iron sheets on our. There suppose those people having their iron groups. Okay, it's made up from this metal only, and this metal iron metal is converted into a thin sheet, and this property is called the malleability. Then sonorous means they can produce the sound. They can produce the sound. If you see the example of any metal near to you, you can take any metal and just strike on it or something, put on it, or you can strike that metal on any other thing. Then also it can produce the sound. Okay, but about non-metals, if you see there so many non-metals are there, it's not possible. They are non-sonorous. Okay, then next one, their ductility. What is meant by ductility? Will tell me about ductility. Yes.
Metals are converted into wires.
Yeah. Metals are converted into wire. This is called the ductility. If you see there are so many metals wire we are using in our day-to-day life. If you see your electrical cables made from metals only. Just if you see there outside, those are electric wires. Those are pole wires. If you see that also made from only these metals. There are different types of metals used for this, but this happened due to only these metals properties or characteristics. About non-metals, if you take non-metal, which is the non-metal? If you take the sodium, this is non-metal. The sodium we can convert into wire, not it's not possible. So, but if you see the copper, this copper we can convert to the thin wire. As well as if you take the example of metal, like the iron, we are observing there so many metal wires are surrounding us there present. Okay. Then next thing about these lusters or then malleability, ductility, melting point, boiling point, and metals are hard in nature. Metals are hard in nature. Just only one example is the graphite, which is not hard. Okay, but about all metals, if you see there, they are hard. And one more example, if you see there, mercury. Mercury, have you seen this mercury? Mercury is metal or not?
Yes, sir.
Mercury is metal or not?
Metal, sir.
If you see there, mercury is present in the form of liquid or semi-solid. Okay.
Liquid.
Yeah, it's a liquid or semi-solid, we can say, and it's more than the other all metals there. So these are. Yes. Anybody want to speak? Okay. So about this mercury is a metal, and if you see there non-metals are there so many things. Will tell me now non-metals their examples. Everybody can tell because we have learned already. Sarthak Patil, can you tell? Sweta Thorat, non-metals example. Pranjal Nade, Nilak Pratimesh, Alicia, Adav Sakshi, Payal Lasure,
Oxygen.
Oxygen. Okay, Sarthak Popse.
Nitrogen.
Hydrogen, chlorine.
Chlorine, very good. Sindhya Abhishek, can you tell?
Carbon.
Oh, very good.
Silver, silicon.
Yeah.
Phosphorus.
Sulfur.
Very good. So, Om Thorat, boys, you have to speak. Huh? You are present, voice not speaking anything here. Huh? Okay. So now we are going to see about the difference between we have seen their metals and non-metals. Now, what is meant by sonority? Those metals having the ability to produce the sound that's called the sonority. Okay. Now we are going to see next thing about it. 1 minute. Okay. About the melting point of sodium, potassium, mercury, gallium are very low. Sodium is also one example of your metal. And if we speak about the non-metals, there are so many non-metals are present. That's are they are not crystal structure. Exception is there only one. That is the bromine. See that bromine is the exception for this. It can shine and as well as it's exist in the liquid state. Okay. Other all are you will see there about the metals. Maximum metals are present in the form of solid state. In the form of solid state, and only few metals those are not present in the solid state. And the exception there we can say about the mercury, which is found in the liquid state or semi-solid state. Understood? Yes or no? And metals are good conductor of heat and electricity. Remember, metals are good conductor of heat and electricity. Like these non-metals are not good conductors of heat and electricity. Are you getting it? Understood or not? Any problem here about these metals and non-metals?
No, sir.
No, sir.
And one more thing about the iodine. Iodine is the exception in the non-metal, which is the shiny. Okay, it's a crystal and shiny. Okay, about the iodine and about the bromine, keep in mind. Okay, bromine is a, you will see, it's the exception. Sodium as well as lithium, these are also metals are there. Okay, and about bromine, what I told you, can you tell me? Bromine in exist in liquid state. It's a non-metal. And another one is iodine is the crystal and shiny structure. Okay. Now we are going to see the next thing, that is the chemical properties of metals. So what are the chemical properties of metals that we have to see? Students, are you getting my screen is there blurry? Can you tell me?
No, sir.
Like as some lines are coming, not like this, no? Okay. So now we are going to start chemical properties of metals. So which are the chemical properties that we are going to see here? Okay. So before that, which substances are good conductor of electricity and which substances are bad conductor of electricity? Will tell me.
Graphite.
Yeah. Graphite. Graphite is the good conductor of electricity. Okay. And in other examples, can you tell which are the bad conductors of electricity? Will tell me. Okay.
Diamond.
Yeah, there are so many examples you will see there. Those are non-metals maximum. They are the bad conductors of electricity and heat. But those are example maximum metals. They are good conductor of electricity. And we have learned about the good conductors of electricity. Those are usually used to flow of electricity or to passing through it conductors that electricity easily. That substances are called the good conductors. And the exception is only that diamond, which is the bad conductor of electricity but good conductor of heat. This remember in mind always. Okay, the diamond is the bad conductor of electricity but it is a good conductor of heat. What is the reason behind that? Can you tell me what is the reason?
It has high boiling point.
It has high boiling point. Okay, any other reason? Ninth standard we have learned about types of their carbon. In that we have seen the diamond, and diamonds it's their structure, which is a hexagonal structure is there. That all sides is packed. There is no chance to flow of electricity. Why? There is no free electron present in the diamond. So due to that reason, it's a bad conductor of electricity. Now one example is there given. Try this for you. So that is a pair of tongues of spatula. So this is your spatula. Okay. Then knife is there, burner, etc. Samples of aluminum, copper, iron, lead, magnesium, zinc, and sodium. We have to take and hold the sample of each of the above metals at the top of the flame of the burner with the help of pair of tongues. Okay, pair of tongues means what is there? Like as a we are saying in Marathi, that is for keeping anything intact. We can catch it, which are the hot things. Okay, so it's a pair of tongues. Yes, are you getting it? Pair of tongues, please. Yes or no?
Yes, sir.
Some are using their sayings, different words for it. Okay, in Marathi, some are saying that chimtas, some are saying that pakkad. There are so many words are like this. Okay. So, if you see these samples of aluminum, copper, iron, lead, magnesium, out of this, which substances are going to catch the fire? That tells where to find it. And how does the surface of the metal appear on the catching fire? So, we have to see these all things by the reaction of metals. That is the first reaction of metals with oxygen. What is that? Reactions of metals with oxygen. When metals, remember, very simple. There are 6 types of reactions. That is the first one, reaction of metals with oxygen. When metal reacts with oxygen, it forms oxides. Remember, it forms metal oxides. And very simple that only this sentence you have to keep in mind. Metals combines with oxygen, it forms the metal oxides. So one example is given: sodium and potassium are very reactive metals. Serious. Sodium and potassium are very reactive metals. Sodium metals combines with oxygen, it form sodium oxides. Okay, or oxides of some metals are soluble in water. See that oxides of metals are soluble in water. Sodium metal combines with oxygen in the air even at room temperature and forms sodium oxide. Remember this. About the sodium, might be I told or not, I don't know, but I'm going to tell you. This sodium we can't keep in the our environment directly free. It's not possible. Immediately it can catch the fire when it will become with the contact of oxygen. Okay, but it's not happen actually. Just it convert that into the smoke. Okay, getting it? तर सोडियम मेटल जर तुम्ही असं उघड्यावरती ठेवलं तर ते लगेच फायर कॅच करतं, कारण ते हायली रिएक्टिव्ह आहे. कोणाबरोबर? ऑक्सिजन बरोबर. हे लक्षात ठेवायचं. गेटिंग इट? येस ऑर नो? You have to speak, students.
Yes, sir.
Very simple. Metals combines with the oxygen, it forms the metal oxides. Okay, and we'll take our regular example. Sodium reacts with oxygen, it gives the sodium oxide. So here, how many molecules, number of elements are present? That only we have to see there. 4 molecules of sodium is present and 2 molecules of oxygen, and we are getting there. Same here, twice Na2O. If you see, you are getting here balanced equation as well as balanced chemical reaction. Okay, and it easily catch the fire. So due to that reason, we have to keep this always in kerosene. The sodium we have to keep in kerosene. If we will try to keep in water, then also it's harmful. It's oxides we can keep in water. Remember, it's oxides. Sodium oxide we can keep in water. It can soluble in the water, but directly sodium we can't keep in water, because in water oxygen is present and it can catch the fire. Remember that. And they can react with water to form alkali. Okay, they can form the alkali. Alkali means bases. Okay, so here you can see this reactions Na2 plus H2SO, H2O in bracket L. L means liquid, S means solid. It gives twice NaOH, means what is sodium hydroxide. Getting it? Yes or no? समजतंय का? का नाही समजते? समजतंय सगळ्यांना काय चाललंय ते? साई शिंदे,
Yes, sir.
पूर्वा, सर्वज्ञ मैले.
Yes, sir.
Okay.
Yes, sir.
So now see, this only one sentence is very important here, but these all things, there those are given. These metals combines with the oxygen on heating in the air, metal oxides are formed. Okay, so in this reaction, whatever reactions are given, that you should know very well. Any one reaction can ask through this. Remember. Okay. Now here about this is the one common reaction asked by the board exam also they're saying that when magnesium reacts with oxygen, what will we get? So we are getting there magnesium hydroxide or magnesium oxide first, and then this magnesium oxide reacts with the water, then we'll get a magnesium hydroxide. Here, you have to write only students know that this magnesium formula, oxygen formula, but they don't know how many molecules they have to take in this reaction. So twice Mg plus O2, it gives twice magnesium oxide. And when this magnesium oxide reacts with the water, it gives the magnesium hydroxide. Getting it? Yes or no? Now, next thing we have to see here, reaction of metals with water. Just we have seen when metals reacts with the water, it forms magnesium, it forms the hydroxides. Okay. So here is a one same given there apparatus beaker samples of various metals. Important note: sodium metal should not be taken. Remember this in water. Okay. So we can perform this all experiments. I am going to show you one by one. If today I will get time. I will perform that experiments. I will send you its video. Okay. So, sodium and potassium metal are react rapidly and vigorously with water and liberates hydrogen gas. What happened there? When sodium and potassium, the sodium is Na, it reacts with water and it forms the sodium hydroxide. It forms the hydroxides and it releases the hydrogen gas plus heat. In this reaction, what produced there? It releases hydrogen gas, it produces sodium hydroxide as well as heat. Means while this reaction is going on, that time that so chemical whatever we are holding in that beaker or anything, it's become there. We feel that it's become there hot. Okay. So why this happen? Because it's this reaction is vigorously with water and rapidly. Immediately it can show its this process and it's liberate the hydrogen gas. Okay. So sodium and potassium reacts with the water. It forms the hydroxides of metals and release the hydrogen gas through that reaction as well as produce the heat. Okay, understood? Yes or no? Are you getting it or not?
Yes, sir.
Yes, sir. Yes, sir.
Okay. So now here for the sodium, you know that chemical formula Na then K. Okay, that remember for the potassium. So where we are going to see about the calcium. Calcium is reacts with water very slowly and less vigorous. So the hydrogen gas is released in this reaction, but in this reaction it collects on the surface of the metal, and it's in the form of bubbles, and the metal floats on the water. So when calcium reacts with the water, it gives their calcium hydroxide. See that, but it's there less vigorous, less speed is there, and it produces only hydrogen gas. It does not produce the heat. Okay, so some metals are given downside. You can see there aluminum, iron, zinc. Aluminum, iron, zinc. When aluminum reacts with the water, it gives aluminum oxides. Okay, plus thrice H2. When Fe means iron. Okay, Fe means iron, and Fe it's Latin word, you know that ferrous. When ferrous reacts with water molecule, it gives what it will give. Can you tell me Fe3O4 ferric oxides? What is it producing? Ferric oxides. And when zinc is reacts with water, it gives zinc oxide plus it's release the hydrogen gas. You getting it? Yes or no?
Yes, sir.
Take the sample of the same metals as in the earlier activity to perform the activities given here. Put some pieces of the sample separately in beakers half filled with cold water. Which metals reacted with cold water? Answer. Magnesium reacted with cold water. Did any metal catch fire in water? Answer. Metals like sodium react vigorously with water and catch fire.
Just I told you before it, this sodium metal only it can catch the fire. Other metals can't catch the fire. Okay. So you will see here this calcium
Think
metal.
after some time. Answer. Calcium starts floating after some time. Observation. Answer. Metals like aluminium, iron, and zinc do not react either with cold or hot water, but they react with steam. Metals like potassium and sodium react vigorously with cold water. Sodium reacts with water to evolve hydrogen, which immediately catches fire, producing a lot of heat. It is an exothermic reaction. 2K plus 2H2O.
Now, what is the exothermic process? Can you tell me? Already we discussed about it. Exothermic. Endothermic and exothermic reaction we have seen in lesson number 3. Will you tell me about it?
The reaction in which heat is gained is called endothermic reaction, and the reaction in which heat is released is called exothermic reaction.
So when we are going to speak about exothermic and endothermic reaction, in that reaction, heat is absorbed. That process is called the endothermic reaction, and in which reaction heat is released, that reaction is called the exothermic reaction.
Gives 2KOH plus H2 plus heat. 2Na plus 2H2O gives 2NaOH plus H2 plus heat. Calcium reacts with water less vigorously, hence the heat evolved is not sufficient for hydrogen to catch fire. Instead, calcium starts floating because the bubbles of hydrogen gas formed stick to the surface of the metal. Ca plus 2H2O gives CaOH twice plus H2. Put the metals that did not react with cold water in beakers half filled with hot water. Note your observation.
Now here you will see here, in this here you are getting here vapors are upside. Okay, these vapors it shows there, they reacts with the hot water. Okay, and you will see there, some are reacting very fast, some are very less. So about magnesium, it can catch the fire there. Then less than it there, you will see aluminum is there. Then afterwards, you can see okay. Then ferrous, iron metal is there, then lead, and last one is there, copper metal. Okay, so it's observation in the hot water.
Reacts with hot water to form magnesium hydroxide and hydrogen. Magnesium also starts floating since the bubbles of hydrogen gas stick to its surface. Write the equation for the above reactions. Mg.
So this is the equation for magnesium reacts with water, that is the magnesium plus 2 water molecules to give the magnesium hydroxides and release the hydrogen gas. Okay.